Hello, Philosophy 102. This is a very special moment in our class. This is my absolute favorite part of critical thinking, maybe of philosophy. It is the chapter I am most excited to teach, and it's kind of the culmination of everything we've been learning so far. This is truth functional logic. So let's just put that right in our notes. I've got deductive logic, also SL part 1 here. Truth functional logic. This is what we will begin doing. It's a little scary at first, but it's okay. I want everyone to, in their notes, in their mind, wherever you keep track of this, remember one thing today. I'm going to write it in all caps. Don't be alarmed. We will only learn about individual claims today. We will not look at arguments. Right? And maybe beside claims, we should include or call them premises. So that looks a little angry, I realize now, because it's in all caps, but it's meant to be reassuring, right? So if we take what we know so far and start putting it together, let's first remember that arguments, let's turn caps lock off first, are, think about it, at least one premise and only one conclusion, right? What else do we know about all the information on the page? We know a lot about deductive arguments, right? So the thing I want to point out is that only deductive arguments can be valid or invalid. Though, I suppose, lots of things can be deductively invalid, right? But it's worth noting, as we talked about last week, only deductive arguments can be valid or invalid. So what does that mean? This all taken together means that we will not even begin looking at validity today. We will only single premise, right? Pretty straightforward. And it's not just going to be one single premise, right? But we'll be taking one premise at a time. They don't get added up together just yet. It is way too much to throw at you all in one lecture. So it seems a little strange because our end goal is to determine whether or not these arguments we'll evaluate are valid or invalid arguments. However, we have a whole new vocabulary to work with today and a really complex means of evaluation. So even though you won't get to see the entire system in this lecture, I hope that by breaking them apart like this, it will help you feel more comfortable with the symbolization that we're going to use to evaluate these arguments. So I added this big caveat this time because in the past, students have thought that they could evaluate individual claims or just a single premise for validity. And of course, you cannot do that because an argument is at least one premise and only one conclusion, and only deductive arguments specifically, can be valid or invalid. this means there's no possible way to evaluate a single claim for validity, right? Because only arguments can be valid or invalid. So I want you to keep that at the fore of your mind, and don't try to say whether or not your homework assignment or any of the things we look at are valid or invalid. Today we are just looking at individual claims. So with that in your notes, let's return to the textbook. So our outline here is important because we're breaking this chapter into two parts. So today we're going to learn to understand the basics, that's terrible, understand the basics of truth tables and logical symbols, and we're going to learn how to symbolize compound claims. This is going to start by building our logical vocabulary. Next week, we will evaluate truth functional arguments using more or less common forms, some uncommon ones. And we're actually going to use a different method, well, although it is deduction. We're going to use a method called truth tables to discover whether or not an argument is valid or invalid. So again, we're breaking this into 2 days. Do not get confused on the homework. It's fairly straightforward. We're just looking at single claims, right? A single claim or a single premise might be something like, if I go to the store, then I will buy apples, right? Very straightforward. We've been doing arguments this whole time, and I find that transition quite jarring. So if I haven't belabored that point enough, let's move on. Given that this is my favorite chapter, I'm going to take a moment with the introduction. The earliest development of truth functional logic took place among the Stoics, who flourished from about the 3rd century BCE until the 2nd century CE. But it was late in the 19th and 20th centuries that the real power of truth functional logic, also known as propositional logic or sentiental logic, became apparent. So it has lots of different names. SL is very common, and what I like to refer to it as, but propositional logic, right, because it evaluates propositions, is also what this logic is called. It's very old, it's been around for a while. We have a lot of names for it. You don't need to memorize those, but don't be threatened by them. They all mean the same thing. It's the logic of sentences, right? So claims, that makes sense. It's one of the bases on which modern symbolic logic rests, and as such, it's important in intellectual areas, such areas as set theory, which you've heard me mention before. I mentioned it a bit last week when we were looking at categorical logic, and the foundations of mathematics. If you've ever wondered why 2 + 2 = 4, it's because there's a proof for it. That sounds odd, but logic rests beneath or behind or before mathematics. We won't go into how and why that is, but if you are at all curious, please reach out to me. I think logic is incredible, and I would be more than happy to explain to you different logical systems that build this foundation for all of mathematics. More importantly, I think it's the model for electrical circuits of the sorts that are the basis of digital computing. And I would add beyond that, I've mentioned a few times with regard to programming, that programming languages are a lot like the logic we're going to be looking at, right? They've got a few common features. One of those features is there's only 2 values, right? True or false. Whereas if you're in a computer language, it's going to be 1 or 0, right? On or off. This is called bivalence. There's only 2 ways something can go. So an example of this is if I make the claim, the cup is on the table. Either the cup is on the table or the cup is not on the table. And we can look at the world and we can see whether or not the cup is on the table. That matter is a bit more complex than the logic we'll be looking at, but that property of being either true or false is at the basis of this kind of logic that we're going to be looking at today, right? So unfortunately, I'm never going to ask you whether the cup is or is not on the table, but we're going to consider all the different ways a claim like that can be interpreted and the different ways that it could be true or false. But it's always only going to be entirely true or entirely false. That's maybe my favorite thing about this kind of logic. So I don't want to go on for too long. The book does for quite a while, but if you're considering going to law school or taking the GRE or even the MCAT, anything that involves logical reasoning, this will help you more than I have words for. I almost want to add a bunch of tags on this video for people considering taking the LSAT, because this is just such an excellent basis for approaching those logical reasoning problems you're going to be confronted with in your chosen career field and in the exams that lead up to it. But let's just dive right in. We can see here that the textbook notes, if you're not comfortable working with symbols, the upcoming sections on truth functional arguments and deductions might look intimidating, but they are not as forbidding as they appear. We presume the whole matter of a symbolic system is unfamiliar to you, so we'll start from absolute scratch. They say that, but I don't think they do, so we're going to deviate from the book just a little bit as we go forward. I have another textbook that I'm going to be using from time to time as we go over this chapter, because, hey, two heads are better than one, right? So be warned about that. We will go much slower than the textbook does in this class. This next sentence, though, should not be ignored. Everything builds on what goes before. It's important to master each concept as it's explained and not fall behind. Catching up can be very difficult. If you find yourself having difficulty with a section or a concept, it says put in a bit of extra effort to master it before moving ahead. You can also email me and I will help you out. It does pay off in the end. So I'm going to draw analogies between this and arithmetic again, because the symbols that they're referring to here aren't any different than the symbols that we use in arithmetic, right? We have an equal sign, and we all know what that means, more or less. We have a minus sign, we have a plus sign, we have a divide symbol, and we have a multiply symbol. I hope I didn't already say that. Anyway, you look at these symbols and you recognize them in the same way you recognize the symbols that make up the words on this page. But of course, when you were learning to read or when you were learning to do arithmetic, these things were unfamiliar to you and the rules about them seemed completely arbitrary, right? Like, just take, for example, the soft C or the hard C, right? How do you know whether or not the C that you're seeing on the page there that I've highlighted is soft or hard? And you have to learn all these seemingly incredibly complex rules about all the letters in the alphabet, and then also punctuation, and it seems like it's never going to happen, and then you understand it and reading becomes second nature. We are only really learning 4 or 5 symbols today. I say 4 or 5, it's because one of them I don't use very frequently, but our textbook does. And you know, they have rules to them, and we do need to learn those rules before we move ahead, but they're no more complex than the rules for a plus sign or a minus sign or a multiply or divide sign, right? Or an equal sign for that matter, right? So they're weird, but I promise with a bit of practice, you can master them relatively easily, and I am your professor, so I am here, I am accessible. Please reach out to me if this just seems like it's an entirely new language. I mean, it is. It is a new language, but it's made up of very few symbols. So hopefully we will get through this without much fear. And I think that's all I want to say. Maybe I'm scaring you guys more by going on about how intimidating this can be. I just want to emphasize that you can reach out to me if you're struggling with something. Please be specific about what you're struggling with, otherwise I can't help, but you can reach out to me. So the first thing we're going to actually learn in this chapter is what our logical vocabulary is. So our logical vocabulary is going to consist of the symbols and the sentence atoms that we will be using as we learn how to do truth functional logic. And we'll take a bit more time with this than the textbook does right here. So the first important thing to note is that we're going to use letters of the alphabet to symbolize claims, and I suppose terms. We did this last chapter, but the way we approach it is a bit different here, right? We used uppercase letters to stand for terms in categorical claims. However, here we use uppercase letters to stand for claims themselves, right? Our main interest is now in the way that words such as not, and, or, and so on affect claims and link them together to produce compound claims out of simpler ones. We will have symbols for not, we'll have symbols for, well, we'll have a symbol for not, we'll have a symbol for and we'll have a symbol for or. There's some other ones not mentioned here, but that's effectively all we're learning today and how they operate. So the important thing is not to confuse the P's and Q's called claim variables that appear in this chapter with the variables used for terms in chapter 9. I emphasize that they were different kinds of logic, so they functioned differently for moments like this. So you'll note that the textbook right here jumps right into this sort of stuff. But I want to use this other resource, which is available online, and I will link in the video description, that there's something really important about the claim variables that we choose when we choose them. So I'm going to call up this new textbook now, and we'll proceed from there. So we are now looking at a much less fancy textbook. It is called For All X, which is a notation that we will not learn because it is way too advanced. But we're on chapter 2 if you want to get this book and follow along. Chapter 1 is great. We just unfortunately do not have time to go over it, and I think the lead-up work we've done means we don't need to look at it right now. So this textbook is calling our claim variables sentence letters, but I don't think that's problematic. So we know that our sentence letters represent our claims, and those sentence letters are capital. So, well, maybe I should give you an example first. So if I said the cup is on the table, and that's my claim, right? My first premise. I might symbolize this with the capital letter C. C does not stand for cup as it did in the last chapter, right? C stands for this whole claim, the entirety of the claim, right? Let's do another one really quickly. Let's say I made a claim like the cup is on the table and the rug is on the floor, right? What do we do with that? Now, I could symbolize that with an F, but as we're going to discuss momentarily, the way we want to symbolize that is as such, because when we look at it, it's really two separate claims, right? The cup is on the table and the rug is on the floor. So, and then we've got this weird guy hanging out in here, which we will talk about momentarily. But not too hard, not too intimidating. This seems obvious, right? There's an essence to this, just like there's an essence to categorical logic that I feel is missed by this explanation. So back to our for all x textbook. So again, in SL, capital letters are used to represent basic sentences. Some of you might be saying, oh, well, that second one wasn't a basic sentence, and good job, you're ahead of the game. Considered only as a symbol of SL, the letter A could mean any sentence. So when translating from English into sentiental logic, it is important to provide a symbolization key. On your homework, I will provide the symbolization key. The key provides an English language sentence for each sentence letter or claim variable used in the symbolization. So for example, let's consider this entire argument. There is an apple on the desk. If there is an apple on the desk, then Jenny made it to class. Therefore, Jenny made it to class. Quick note for anyone who's terrified of this just means therefore. That's the symbol that I'm not going to use, but it's part of this. I don't know, maybe I can add a little comment here so that this says therefore. As it turns out, that looks quite silly. But you can see that this just means therefore. Oh, and now it's gone. Okay, well, there we go. This means therefore. Don't stress it. Not a big deal. Therefore, Jenny made it to class. Right? So this is obviously a valid argument in English. I don't know that it will be obvious to you guys, so feel free to take a moment to look at it. In symbolizing it, we want to preserve the structure of the argument that makes it valid. Right? That's what I skipped over to this different textbook for, this concept. We've talked a lot about structure, so how do we preserve the structure that makes this valid? Well, let's learn how not to do it first. What happens if we replace this sentence with a letter, each sentence with a letter? Our symbolization key would look something like this. You've got A represents there is an apple on the desk, B represents if there is an apple on the desk, then Jenny made it to class, and C represents Jenny made it to class. Right? We would then symbolize the argument this way. And then A, B, therefore C. Right? That looks a little kooky, but we don't want to do this, so I'm not going to worry too much about it. A, B, therefore C. Can we look at that and tell that it's a valid argument? I don't think so. I mean, I know we cannot. This doesn't mean anything. Premise 1, A, premise 2, B, conclusion, C, right? We've talked about this before. You can't just introduce new things in your conclusion. So what's gone wrong here? Well, what's gone wrong is that there's no necessary connection between some sentence, A, which could be any sentence, and the other sentences, B and C, right? As we mentioned, we could use A to represent anything. We could use B to represent anything, and C to represent anything. They could all be any sentences, right? A could be a sentence totally unrelated to B. We can't tell that it's valid. The structure of the argument has been completely lost in translating it into our logical vocabulary, right? So the important thing about the argument is that the second premise is not merely any sentence, logically divorced from the other sentences in the argument. The second premise contains the first premise and the conclusion as parts. So what does this mean? Let's get this in our notes, and I hope you will all pause it in order to get this in our notes, or in your notes, and type this out in full. So I'm not going to do any organization right here, but get rid of these things. All right, so English argument. And then maybe something to separate us out a little bit. Oh, that was very dramatic. Okay, let's just keep the little dotted line. All right, and then let's go back down. And this is a lot to put in your notes, but I think this is just fine. And I'm going to write the word therefore instead of using this symbol. Therefore, see. Right, and we can even label these, as I've been doing for you guys. It will become problematic to continue to label them as C. So you can write conclusion, you can use the 3 dots if you want. It just visually is hard to offset from this letter, right? And starts looking more and more symbolic. So we can see that this preserves that structure, right? If A represents there is an apple on the desk, we keep the word if, and then just drop that A in here and create another sentence for Jenny made it to, or another sentence letter for Jenny made it to class. And then we get to, therefore, Jenny made it to class. We can see that the second premise contains both premise 1 and the conclusion. This is all that textbook means when it says, preserves the logical connection between the premises and the conclusion. So when symbolizing, this is incredibly important. We can pick whatever these are at random, right? I could make this P, and I could make this P, and I could make this Q, and also this. And even though, this has apple and class in it, this is still a perfect symbolization of this argument. What the letters are don't matter in particular. Again, it's the structure that matters. So as you write this down in your notes, I hope you take a moment to think about what that logical connection is that makes this argument a valid deductive argument. So what's the lesson we've learned from this whole big mess that required 2 books to teach? Capital letters. Sometimes we use Greek letters, sometimes we use letters with numbers attached to them. That's just if we run out of letters in our argument. So letters in SL, represent claims. That's it. The entirety of the claim. So here, P equals there is an apple on the desk. Well, not dick. And Q represents Jenny made it to class. I'll refer to what I just did here as a symbolization key. It's no different to a map key or any other kind of key. Well, it's not a physical key, but it's no different than any other key that you'd use in these contexts. It just tells you what the letters refer to, and then you can translate. If you were one of my students last class who was struggling with letter representations, I told you they were okay for a time, but we would have to move past them because it will start to slow you down. This is that moment when it will start to slow you down. So you need to get used to looking at the symbolizations. If you want to continue to make symbolization keys, that's fine. If you want to continue to write above the letters for a while, kind of as a stepping stone, that's absolutely fine as well. But pretty soon we're only going to be looking at arguments as such. They'll actually be a bit more bare bones than even that. So that's the first bit of our logical vocabulary. is letters in SL represent claims. Some of you may be noticing that there are still words in here. What's going on with that, right? Well, we already know therefore can be represented by 3 dots, which I am not going to be using. Oh, that's not what I wanted to do. I wanted to do that. So our arguments will look more like this. I mean, we say conclusion, right? It'll be okay. But what about these guys? What do we do with them? Well, we have symbols for these. So we're just going to begin creating the rest of our logical vocabulary. If, then, is represented by an arrow. And is represented by an ampersand, or when I write it by hand, I use a plus sign. Well, kind of a plus sign. I am trying to learn how to draw an ampersand. I have never been any good at it, but they're the same thing. The word or, which does not feature in this argument, nor does and, is represented by a capital V. And we have one more. It's called the biconditional. Well, actually, we have 2 more. If and only if is represented by a crazy arrow that I have to go fetch off the internet, and again is much easier to write by hand. So we've got if and only if, which you'll notice is the same as an if-then conditional claim, right? It's got an arrow going the other direction. And when you think about it, as we will quite a lot, that makes a kind of perfect sense, because the requirement or the entailment goes both way. If you decide to watch other logic videos, you might see that the instructors there say implies instead of if-then, or conditional, or entails. It's not a big deal. Eventually we get to the point, I mean, theoretically, without any common language between us except logic, we should all be able to read each other's logical claims using only these symbols. Though it is kind of weird that I use this one. I'm working on it, you guys. I'm working on it. But this looks pretty ugly. So if you want to just organize this a little bit in your notes, or if you take handwritten notes, you know, put some quotes down or something, highlight these things. I'm going to take this out of here because it's not too hard to see that you'll get it. Okay, so this is almost all of our logical vocabulary. We have one more symbol, and it is called the negation. And it functions differently than do these other symbols. These symbols are all called connectives. They connect sentence letters. Negations negate a claim, right? That's a lot to take in right now. So let's get some examples. Why don't we use this argument right here? I want to challenge you guys. Well, let's just do one at a time, because I promised we wouldn't do arguments today. Let's just symbolize, if there is an apple on the desk, then Jenny made it to class. So oh, that was the worst possible time that could have happened. Okay, so we've got our symbolization key here. We know that P represents there is an apple on the desk, and Q represents Jenny made it to class. So it's okay that that's off screen. I'm just going to say we're going to be symbolizing this sentence right here. So P, that's it. These say the exact same thing. I can look at the P and the Q with the arrow in the middle. I know that represents if-then. It connects the two claims, right? Let's get back up to look at that, right? There is an apple on the desk and Jenny made it to class, right? And when we symbolized it before, it wasn't that different. It's P, if P, then Q, right? This down here means the exact same thing. So we have now successfully symbolized a claim. In fact, it was a compound claim. So we're not going to be looking at that other textbook anymore, although I encourage it and I would love to get questions about it. It's an open source textbook, which is pretty cool. Well, I don't know if you'd call it an open source textbook, but it's totally open. The creators of it made it available for free online. They're wonderful logicians, and they're my favorite sorts of nerds. So we appreciate them very much. Thank you guys for helping logic and education. But we won't be looking at it anymore. So we've got one claim symbolized right here. Now let's talk about what we can do with this beautiful creation we've made. Let's move back to our lovely textbook and talk about our next section, and that's truth tables. Oh, the bulb stayed on. Worse things have happened. Okay, truth tables. What do we do with this? This is kind of large. We've got a lot of things going on, but that's because we developed our logical vocabulary before the textbook did. So this is a bit much. We're going to consider truth tables and symbols. In truth functional logic, any given claim, that given claim being P, for example, is either true or false. As I said before, it's bivalent, it's binary. It's never going to be half true and half false. And you may be saying to yourself, well, what if the cup is halfway off the table? I would say the cup is still on the table. Even if it's exactly halfway off the table, the cup is, assuming it's still resting on the table, the cup is still on the table, right? It is not simultaneously both on and off of the table. If you take serious issue with that, there is a kind of logic called fuzzy logic. It's actually, as I understand it, what is used in Roombas and a lot of smart thermostats and rice cookers, oddly enough. That have ambiguous areas where something's not hot or cold, right? It's just warm. But for the sake of this class, we're going to consider these things as true or false. And the claims we will be looking at will realistically be either true or false. So for any given claim, let's say P, there's two possible things it could be. It could be true or it could be false, right? Before you see the cup, if I tell you the cup is on the table, you understand that that is either true or false, right? So we're going to move over to Photoshop for me, but you can continue to put these things in your notes. I would recommend handwritten notes because it's going to get very difficult in the Word document. So we've got this ridiculous blank screen with this claim, the cup is on the table on it. We're going to continue to look at that. I'm going to make a symbolization key here, just as the cup is on the table is represented by the letter P. So I can't see my cursor, I suddenly realize. So we've got P here. And we want to discuss every possible way that P, that was a mess, that P could actually be. So we create this thing. Well, the cup could either be on the table or it could be false that the cup is on the table. So without evaluating whether or not the cup is on the table, we know that there is exactly two ways that this claim can turn out to be true. So we're creating possible worlds here, right? And this might seem a bit silly to talk about this way, but this is world 1 and this is world 2, right? Maybe it might help to think of a scenario. Let's say you are having dinner outside and you forgot your cup inside, and your friend says, well, I'm going inside anyway, and you tell the friend, well, the cup is on the table, can you grab it for me? Right? That's fair. At that point in time, it can either, you could be mistaken, right? Your friend's going to go inside, look at the table, and either the cup is going to be there on the table, or your friend is going to go inside and say, where is that cup? That cup is not on the table. Right? And these are two possible worlds that until your friend goes inside, we cannot really say which is which. So this little table right here, theirs looks a bit different from mine. Who knows why? Maybe because it's a textbook and it's hard to type these things out with vertical lines, is just a truth table. It displays both, which in this case is all, possible values for P. Whichever truth value the claim P might have, its negation, or the contradictory, which we'll symbolize with not P, will have the other value. So we can see that, let's continue creating possible worlds. So let's get another world going over here where we use our negation symbol and P, right? In this world, that's not what I wanted. In this world, what is not P going to be? In the world where I send my friend inside for the cup and it is indeed on the table. Not the cup is on the table is going to be false. Pretty straightforward, I think. Now, in the world where the cup is not on the table, I send my friend inside, we're in world 2 now, and they go inside to find this cup and it's not on the table, it's then true that that cup is not on the table. So not P gains the value of true in this world. That's all this book is trying to explain. It looks quite complex, but I think thinking of them as possible worlds will really help us out. You may be saying to yourself, okay, so this is straightforward, but what about that claim in my notes, the if P, then Q claim? What's going on with that? I don't see how that fits in here. Well, that has some significant differences, right? It has two values. It's not just the possibility of the cup being on the table and the possibility of the cup not being on the table, right? There's a whole lot more going on here. So let me clear this. We'll set it up for a new table. So what we have here is a conditional statement, right? Man, I sure wish that cup were on the table. Okay. So if the cup is on the table, then it is full of beer, right? What do we do with this? Well, the first thing we need to do with this is recognize that there are two parts to this claim, right? So we need to symbolize each part. And just for ease of space, I'm going to write the symbolization down below it. So we've got a P and we've got a Q. What do we also have? We have this important conditional relationship between them. So we now have an if-then statement symbolized, right? If P, then Q. So how do we go about creating the worlds? All the possible ways that this cup and this beer could be. Well, we start out the same way we started out before, with our line, right? And we say true or false, right? But then we've got this other variable here, which is Q, right? Well, Q can also be true or false, right? But does that cover every possible world? Either it is on the table and it is, or it's not and it's not full of beer. I don't think that covers every possible arrangement. So let's get rid of this stuff we just wrote because that's not right. What's wrong here? It should be, those of you who are more mathematically minded may realize that as soon as you have two variables, you have more possible arrangements of those variables, right? So we need more rows. And typically these are arranged differently, but it's for demonstrative purposes. Okay, so now we want to create every possible combination of P and Q, of the cup being on the table and the beer, right? Maybe the cup's on the table and I'm lying, it's not full of beer. I just hope my friend will get me beer, right? Maybe it's full of beer, but I sat it somewhere else, right? There are lots of ways this could have played out. And I'm going to move through this fairly quickly because, I'll explain why momentarily. So I want you guys to look at this and ask yourselves if I've created every possible combination of these things. It looks like I have. The cup could be on the table and it could be, it's just so bad, could be on the table and it could be full of beer. The cup could not be on the table, but it could be elsewhere in the house full of beer. The cup could be on the table, but it could not be full of beer. Maybe I drank it all before I went outside, right? Or the cup could be not on the table and also not full of beer. This is every possible arrangement of these two variables. So how did I figure this out so quickly? Realistically, I do this a lot. Not this exactly, but this a lot. But there's actually an equation for this. The number of rows or possible worlds you can have is 2 to the power of n, right? And this n is just the number of variables, right? You don't need to memorize this. As our claims get more complex, we're going to learn a much quicker way to do these truth tables that won't be nearly as involved as this. And they're called short truth tables. These are called long ones. And this will just be far from your mind. But for now, as a means of explanation, or if you're just curious about equations, it's 2 to the power of whatever. I guess that looks like 2 times n, doesn't it? You should draw a little n right there. This is how we figure out the number of rows, or as I call them, possible worlds. I've taken a moment to move our equation up to the upper right-hand corner. It's not part of the sentence. I just moved it over there so that we could move on. So what do we do with our claim that we are evaluating now that we've created every possible scenario? So the first thing we're going to do is we're going to draw another line, not like that, maybe like that. I'm not good at these vertical lines. I need to reposition everything. Okay. And I'm just going to draw this and then start recording again. That's a little better. I think we'll all agree. Oh, I forgot to give us a vertical line. I do something other philosophers do not do. I draw a squiggly line right here. If you watch other videos, they won't draw a squiggly line. This is just to separate our worlds, right? Possibility, right? Possibility from our evaluation. And so our eval will go right here in under this, and this just separates it. So we've got this claim, if P, then Q. Well, there are a lot of different ways this could turn out. I think we will agree, right? I should reset this as well because this is a mess. So we'll talk about that. I want to say that looks much better, but the truth is it doesn't. I do want to take a moment to point out that I have rearranged these so they match up with the ones in your textbook, as well as with convention within philosophy. So now the true, true, false, false is on the left side, and the alternating true, false is on the right side. It's still the same possibilities, right? I haven't invented a new possible arrangement of P and Q while I was organizing this. This is just more conventional and will make it easier to follow along in the textbook. So moving on, we've got this if P then Q situation here. So let's talk about it in sentence form. If the cup is on the table, then it's full of beer. So I tell this to my friend who goes to retrieve my cup. This is my claim about the world. I'm making a claim about the reality that my friend and I occupy. If the cup is on the table, then it's full of beer. Maybe I've made a drink for my friend who's just come by, right? It can be anything. If the cup's on the table, then it's full of beer. That is a rule about the world I have just created, right? And in world 1, it is true that the cup is on the table, and it is also true that it is full of beer. Have I lied to my friend with my claim? If the cup is on the table, then it's full of beer? Well, I think not. So we're going to go ahead and say that that's true in this possible world, right? So what about world 2, where I say, if the cup's on the table, then it's full of beer. And my friend goes inside, and the cup is on the table, but it is not full of beer. Have I lied to my friend? It would seem that I have indeed lied to my friend. So again, in world 3, I say to my friend, if the cup is on the table, then it's full of beer. And as it turns out, the cup's not on the table, but it's somewhere else and it's full of beer. Have I lied to my friend? This one tricks people a lot, so don't be alarmed if your natural instinct is different, but really think about it. I say, if the cup's on the table, then it's full of beer. And the cup's not on the table, it's elsewhere in the house, but it sure is full of beer. Now, I have not lied to my friend. Why have I lied to my friend in number 2, but not in number 3? Well, because I said the condition under which it was definitely full of beer. If it's on the table in world 2, it is on the table, but it's not full of beer. That condition has failed, right? But I didn't say anything about world 3, where it's not on the table, where it's elsewhere in the house and is full of beer. I didn't make any promise that if I sat it down somewhere else, it wouldn't be full of beer, right? This is maybe the trickiest thing in learning this truth table. Don't stress it too much. We'll talk lots more about it. Okay, we're going to move on to world number 4, where my friend comes over and I say, hey, if the cup's on the table, then it's full of beer. And the cup's not on the table, and it's not full of beer, right? Have I lied? No, I have not. It should be pretty apparent I haven't. I said if. Right? This if carries a lot of weight. If this feels sneaky to you, I would say set that feeling aside, because we're evaluating this claim, right? There are other symbols for other types of claims. But if you make an if claim and the first part, the antecedent, fails, it doesn't happen, there cannot be a lie. There simply cannot, because you've only given the conditions for the circumstances in which it is indeed the case. So If you have an F in this first position, you get the truth for free, right? Because you've said if. And again, I hope that doesn't seem sneaky. As we go over the other truth tables, it will become less exhausting. Okay, so with that said, this is the complete truth table for the conditional. What I've given you guys right here, it kind of looks like a beer cup. What I've given you with this is simply every rule for how we treat this symbol. So as I said, I will keep comparing this to symbols in math, right? If you see a minus sign, you know what to do. The position of the first number is relevant to the position of the second number, right? So if I said 4 minus 2, for example, that would equal 2. Whereas if I said 2 minus 4, that would equal negative 2, right? The positions matter, but that should be obvious to you. You should not be, maybe not obvious, but you should not be intimidated by what you're looking at. We're just looking at the order of these things and how to think about the claims. And I promise you do this in your own heads every time somebody says something to you, like, if the cup's on the table, then it's full of beer. Okay, I'm going to clear this out, and then we will look at our other symbols. So what if I say to you, the cup is on the table and it's full of beer? Oh, that one's going to be quite different, right? So the first thing we should do is symbolize this. And again, I'm just going to draw my symbolization key as such. So this is P, and this is Q, right? Now is the moment. I warned you guys it was coming. I'm going to symbolize and this way, because do you really want me to, like, what is that? I don't know. We're not. Okay, so I can do it, but it's awful on Photoshop and embarrassing. So you'll never see me do that again. We're just going to use the symbol, and I hope you guys can learn to be okay with that. So we've now symbolized this. We have our claim. It's just written out huge up here, but we haven't created our possible worlds. So this setup is going to be the same every time. In fact, I'm going to pause it and set it up in advance. All right, so what mess do we have here? Hopefully something that is legible, right? You'll note that we have the same number of possible worlds because we have the same number of variables, right? And we've arranged them in the same way because this is just a given, right? There's no need to go crazy and wild with the order of your possible worlds. In fact, it will make things more difficult if you do. So we're just going to evaluate this claim, and I'm going to continue to use English sentences as we talk about it. The cup is on the table and it's full of beer, I say to my friend. In possible world number 1, the cup is on the table and it's full of beer. Have I lied to my friend? No. Not at all. Well, that's a weird looking T. Not at all. I have told my friend the perfect truth. So my friend comes over expecting their beer in possible world number 2. And I say, the cup's on the table and it's full of beer. But the cup, while it is there, it's not actually full of beer. Have I lied to my friend? It seems that I have. What about here, where I say, the cup's on the table and it's full of beer? That's a promise I made my friend. Just go right inside. The cup's on the table and it's full of beer. But the cup's not on the table. Somewhere else and it's full of beer. Maybe it's in my hand. I have lied to my friend here, right? When we use a conjunction, when we say and, like this, both parts have to be true. right? I told you that the reason the truth table came out the way it did with the conditional, with the if statement, was a product of what was being promised there. Likewise, if you say and, you need both parts to be true. And finally, in possible world number 4, where I make the claim the cup is on the table and it's full of beer, and the cup is neither on the table nor full of beer, I have definitely played a nasty prank on my friend. I have lied to my friend. There's not even any beer, much less a cup, right? So this right here is, apparently I just cannot draw straight lines. This is the truth table for the conjunction and, right? Hopefully you're taking notes of this. It may be worth noting that whereas the conditional, the if-then statement, was only false on one line, the and statement is only true on one line. It's much easier for a conditional to be true than it is for an and statement to be true, right? Again, both parts must be true in order for the totality of the claim to be true. All right, I'll clean this up and then we'll look at our last 2 symbols and we'll talk a bit about negation. So we're looking at what I should have done in the first place, which is laid this out with straight lines. Thanks for bearing with me through that, as well as a new claim. So let's say I'm continuing on with this idea that I'm having a friend over, and I say to my friend, I will buy beer or snacks, right? This is my promise to my friend. Maybe I'm really lonely and I really need some social interaction and I'm bribing them, right? I promise I will buy beer or snacks, right? So we're just going to go about evaluating this. Oh, look, in my fancy doings, I forgot to label these. Okay, so we're just going to look at all the possible ways this claim could turn out and evaluate it with our or. Oh, we should also label these P, Q. Now you might be noticing snacks appears to represent Q. If we were being really formal about this, it would say, I will buy beer, and then I will buy snacks, and those would be our sentence letters. But this is much easier and more reasonable, and it fits better on the screen. So let's start our evaluation. So in world 1, where I say, I will buy beer or snacks if you come over, right? And it is true that I buy beer, and it's also true that I buy snacks. It is true that I will buy beer or snacks. Some of you may find that a bit counterintuitive. You're thinking of or as being exclusionary, right? Like either or. It's worth noting, I have not said either or. I have not said like I will only buy beer or I will only buy snacks. That's a different claim. So for this or, we use something called the inclusive or. There's a whole Wikipedia page about it that is very fun to read. But it's the inclusive or. So in the possible world where I buy both beer or snacks, I have not lied to my friend. Right? It is true that I would buy beer or snacks, and I purchased both. I'm just that good of a friend. In world 2, where it is true that I buy beer, but false that I buy snacks, and my claim was I will buy beer or snacks, we will find that it is true that I will buy beer or snacks. Likewise, in possible world number 3, where I don't buy the beer, but I do buy the snacks, it is true that I'll buy beer or snacks. This one's seeming pretty easy, right? But then we get to possible world number 4, where I say I will buy beer or snacks, and I buy neither. I do not buy beer, and I don't buy snacks. In that case, I think we'd all agree I definitely lied to my friend, right? So that gets a truth value of false. This is the totality of the truth table for the or connective, right? So I've been doing this thing where I've been reading the sentence out and then going through the worlds. If you need to do that to get off the ground, that is a-okay. If you need to continue thinking about this in terms of a promise or a sentence, and then running down your possible worlds, That's okay. Don't stress it. Make up little scenarios for your claim variables and tell yourself a little story, and then ask yourself under what circumstances a lie has been told. I find it very helpful. All right, we are to our last logical connective. So we've got a new claim in front of us, a new single individual premise with lots of parts. We've got this pesky guy right here, if and only if, right? Which I said would be much easier to draw, and look at that, it is, right? If and only if. And then we've got these clear sentence atoms, right? So we're just going to label this one P, and we're just going to label this one Q. Next thing, we're just going to write this claim down here for our evaluation. And I forgot to number them again. This numbering is non-traditional. If you don't see it elsewhere, that's why. Okay, so let's evaluate this claim. I will buy beer if and only if I buy snacks. Really think about that one, right? The if and only if is a tricky one, but it's a powerful one. And I think probably, if you think of this in terms of promises, you could fill out this truth table on your own, because we're past all the big tricks and whatnot of logic. So in possible world number 1, I will buy beer if and only if I buy snacks. I buy beer and I buy snacks. Have I lied? It would seem that I have not. But in possible world number 2, where I say I will buy beer if and only if I buy snacks, and I buy the beer but I don't buy the snacks, I have indeed lied, right? I said if and only if. Might be worth noting that I think our textbook abbreviates this IFF. And if you go on to study any other philosophy, you will probably see that abbreviation. Okay, anyway, in world 3, where I say I will buy beer if and only if I buy snacks, and I don't buy the beer but I do buy the snacks, I have indeed lied. But again, the if is a little tricky guy. In world 4, where I would say I will buy beer if and only if I buy snacks, and I buy neither beer nor snacks, I have not lied, right? And again, I'm going to just encourage you to think about this. I said I will buy beer if and only if I buy snacks, and then I don't buy either. Seems okay, right? I didn't lie there. This is the totality of the truth table for the biconditional. Right? It goes in both directions, biconditional. We aren't going to use this one a lot. There are some interesting fun facts about all these symbols. We could get rid of all but one of them, but then our sentences would get much longer and it would get very confusing. And that's what you would do in intermediate logic, not in this class. So if you see some similarities between them or ways you can connect them together or express things using different symbols, right you are. That is a very cool thing to have noticed. If not, this is perfectly okay. So I promised that we would talk about the negation. So I'm going to pause this and we will think of a very simple example of the negation to conclude with. All right, so we are looking at a sentence that contains a negation, right? I will not buy snacks. We, as critical thinkers, have a couple different ways we could approach this. We could make our sentence atom the entirety of I will not buy snacks. This could all just be P, in which case we don't have a negation. The negation is included in the P. That might seem easier, but then if I have another claim in which, or if I do in fact buy snacks, we've got a problem, right? How do we parse that? It gets really crazy. You'd actually end up saying not, and stack that double negative, right? If I did turn around and then buy snacks. So in order to avoid complicating this, we're going to let P stand for I buy snacks. Deal with my crazy K. Okay, I buy snacks is what P represents, in which case we're going to symbolize this claim as not P. And again, we have as many possible worlds as we do combinations of our variables, but here we only have this one variable. So no big deal, right? This is pretty straightforward. We symbolize our claim as not P. I will not buy snacks because P means I buy snacks, and we have our handy negation symbol. And we've just made an executive critical thinker choice to symbolize I buy snacks rather than I will not buy snacks with P. So our symbolization comes out as not P for this claim. Again, slightly unconventional way of doing this, but so is my squiggly line, and it seems to go over well. So we've got possible world number one, where I buy snacks, right? But my claim is I will not buy snacks. So have I lied? Maybe my friend who's coming over is dieting and they just are like, no, I can't see any snacks. I'm not having it. There better not be any snacks in that house. And I promised them I wouldn't buy any snacks. And then I turn around and I do. I've definitely lied, right? And conversely, if I promise I will not buy snacks and I don't buy snacks, I have told the truth. So you might notice that this is a little weird looking, right? It's not like our other logical connectives. It's out front of our letter, right? All the other ones connect things. Well, the negation isn't really a connective, right? Don't think of it too much like a negative symbol, but, you know, we can, again, just to relate this to math, we can tell the difference between 2 plus 2 and 2 plus negative 2, even though this uses the same symbol as the minus sign, right? It might trip you up for a second, but it's nothing to stress about. It is pretty straightforward. So this attaches just like the negative symbol does, right? It just attaches on front. It doesn't have to go between two connectives or two sentence atoms the way all our other connectives do, right? So that is everything. We now have a complete toolkit to start next week evaluating arguments, which of course this is just a premise for, right? So we haven't talked at all about validity yet, but this tool becomes invaluable for discovering validity. It's my favorite thing. And you can do this with all sorts of claims, right? We're not limited anymore with the all, some, and none of categorical syllogisms, blah. I shouldn't say that. But we have this robust vocabulary now, and we are empowered to create all these claims that we can then go forth and analyze for structure. So just to recap, we began by discussing how to reduce this complex English argument to its logical form, formally, which is to use sentence atoms, right? We discussed the meaningful connection between sentence atoms and preserving that in our arguments. We discussed all of the logical symbols we're going to be using. And then we went on to discuss all these lovely truth tables. Last thing before we go, I figure it's worth noting that, oh, that was terrible, that our textbook, oh no, I'm just going to pause this. Okay, I found the page again. This information is all in our textbook. So this is a hard copy of the basic symbols. You'll notice they only have 4. They do not have the biconditional in here. And this is on page 288 of the physical textbook and page 416 of the PDF of the textbook. It's worth noting they go through everything we went through, and maybe it's more organized looking to you. They talk about the antecedent and the consequent again, which we will really get to next week when we start looking at full-fledged arguments. But all of this is in here. It may be worth looking at if you hated my Photoshop version of it, or if you just want to take a screenshot and have a chance to write all this down and think it over independent of me preaching the gospel of logic to you. Okay, thanks everyone. Great job. And I look forward to seeing you next week.